So, thanks for the introduction. I'm Julian Thomas. So today I will talk about Android based on the Protektoid project, and this time based on a lot of bug hunting and bug bounty. And so you may have seen me in the past years already talking about Android security, technically speaking, like virtualization, ART structure, hooking. And so today we will still talk about Android. But contrary to the previous year talks, which were mainly technical, we'll see this time that by basically not doing any technical things, we can still do a lot of great things regarding Android security. And the objective of this talk today is to review data management on Android. So when I say data, I mean user data and not application data that we call assets. And basically is to review a lot of bad practices that we still see nowadays and data management by application developers, and to introduce how we can, how they should fix that, or also how can we use the fact that they don't use bad practice, that they don't do good practices to basically hack application data. And also I will make a side apartheid about like bug bounty hunting on Android, and well, what was the experience for a couple of minutes about this kind of activity. If one say what data exposure again on Android, that's not a brand new topic. I will say that when we focus about data leaks on Android, we mainly focus on like the system leaks, like basic core application leaks, such as before we had how we can basically retrieve the user identity based on the stock app misconfiguration. Today the talk will be much more like about like any developed app with a huge user base, bad practices, and how basically by installing this app we leak all our personal data, confidential data, and whatever. And we will not talk about insecure shared data loading, such as basically side code loading. We will really focus on user data, because for example, like we don't really care that we leak the fact that we download the map of Hungary, but we really care that anybody on our device can know where we live, where we work, what's our preference location in Budapest, for example. Okay, so just before talking like really inside the topic, I will just make a small guess, and if someone wants to answer the question, that would be cool. So the environment, you just try to have kind of general setups. You have an app that is installed on the device with only network permissions, so like basically it can just send out data. It's like a genuine app, no rootkit and whatever. And basically your device is not rooted, so like normally you should have a very good security. And well, one bad stuff is that your device has a lot of apps, like really a lot. And for example, you have video streaming apps, remote control apps, remote storage app, or like basically remote data storage app, such as, I don't know, Dropbox or whatever. I mean, one thing is that I said I will not disclose the name of the vulnerable application because of NDAs that were signed. So the question is, in general, or in worst case, among this kind of question, kind of option, what can be done? Can we do like basically asking nothing? Can we do file listing, user identity disclosure, user credential disclosure, remote stored file disclosure, or remote control? So does someone wants to have a guess here? So I would guess myself. Well, basically we can do a lot of stuff. We cannot really do remote control. We can just hack the user into giving us remote control. But apart from this slice apartheid, we can do nearly all the other stuff. I mean, file listing is nearly an off topic that we'll not go into details, but we can do file listing. But we can definitely have user identity disclosure, user credential disclosure, and any file, user file, again, disclosure. So, the talk will be divided in 4 main topics, which is basically the first one is explaining how data storage works technically and security speaking. And then, well, how can we use that? How can we use bad practices to get leaked data? And then, obviously, as I said before, what was the reaction of the vendors regarding either managed or like private bug bounties? So data storage. First, documentation, because it's always good to read the documentation. So I don't want to put some bad words, so I'll just put RM, but it's read the fucking manual. So when we talk about external storage on Android, we have nice calls given to us by the Android framework, Android system, with a nice documentation, such as you want to store your file on the external storage. Well, you can use this function called the get external files dirs, which basically is described as follow. It's an absolute path to application-specific directories internal to the app, not typically visible to user as media. It's a storage that is not always available. Well, obviously it's external storage, and no security is enforced with this file. I mean, like here, when you're not a security expert, you can see that here you have already two sentences that seems conflicting. Like, not typically visible to the user as media, and no security is enforced. I mean, like, unless you pay very attention to the search phrase, you would believe that basically it's not visible to the user. Well, I mean, it is. And then if you look at the get external storage directory, which is another way to access the external storage, well, you will see that storage can, the description, in the documentation is like it can hold a relatively large amount of data, and each user has their own isolated shared storage. Well, I mean, here again, when you say user, it's not an application, because normally in Android, every application has its user ID. No, when you say user, here is user, meaning the only guarantee you have is that each user on Android, like if you log in on the Android, is as an isolated shared storage, but not each application. Yeah. So that was one way to look at the documentation. And then if you look at another way of documentation, I mean, I put the reference below, which is kind of a training. It describes a little better what's the distinction between internal storage, which is basically the files have here are only accessible by the app itself. That's what we call the private data folder. And when you have an install, well, basically all of that is removed. When you have an external storage, it's a word readable. So here normally, like it's kind of obvious that this word readable is written. However, you have two nice features, and we go back on this definition of features after, is that it seems to behave like the internal file, because when you remove the app, well, the data is removed. And the other very interesting stuff is that if you want to share your files with other applications, it's written that it's the best place to use. However, you should look before that it's the best place if you don't require any access restriction and you want to share. Well, I mean, like, you have to repair the documentation, because if you don't, then you will have some kind of misbelief. Okay. So, if we are a developer, not a security expert, but we have a developer. So now, after we read the documentation, well, not truthfully, so very general reading, we seem to see that developers have a correct vision of what internal storage is, because basically they will put on this folder core application data, such as databases, any private data, and low volume data. Because basically, if you want to store a huge amount of data, you will lose the external storage as per documentation. So as I said, you will, for example, store cache, databases, and core files. To do that, developers use the standard code. So like everything seems to be okay when we talk about the internal behavior on application. However, when you start to consider what is the vision of developers regarding non-internal storage, so the external storage, which is, here again, I will go on the definition of what we can call by external. Well, the objectives start to not be so much match of what we can expect from. Because basically, so they will store data. Yeah, why not? They will store shared data. Okay, that's here again the definition. Then we start to store non-core data, meaning like any data that they processed. I mean, like any data as a new process, some of the data are like internal to the app because it's really sensitive. And another stuff is that they will put their files that they want to share with other applications. Because when you misread the documentation, you believe that this is the best, or not to say the only way to share data is basically not to store on private, because if it's private, well, it's private and it cannot be shared. So it's stored on what we call the /sdkd folder. However, here we start to have already, I mean, like even on Google or Android agree that it was kind of a very bad name because SD card, well, it's not SD card. I mean, like it can be an SD card if you put an SD card, but mainly nowadays with the device that have a lot of storage embedded, well, it's basically a storage inside the phone itself. So it's not an external storage. And if you look also at the way the folder are named, you have really similar structure as the internal storage, which strongly give the impression when you are a simple app developer and without many security knowledge that you have the same practices and the same security because you store your file on your own app folder in the SD card. So it's really the same structure as the private folder. And as I said, also the documentation triggers one perspective if you don't read it carefully. So before talking about the security implementation and why we should care about internal versus external, let's talk about what when I used to have an answer as kind of a feature of the external storage. So the first one is that when you read the documentation, you see that if you use some function call, well, you restore a file on the device that is not removed after you uninstall the app. So some people see that as a nice feature for returning users, meaning if you put a file there, the user uninstalls the app and reinstalls the app, well, the data is still here and working. Obviously, well, it's true, but it also means that it's accessible. And the second answer is that, well, we don't support SD card. Like I was talking with vendors that says, look, you have an issue because you store all your files on /SD card. Well, the answer was, yes, we know, but we don't support external SD card, so that's not a problem for us. Well, I mean, no. I mean, like SD card is an internal folder, as I said before. However, as I will also talk at the end of this talk, is that even if these arguments are so obvious to so that they are wrong, don't try to use that in bug bounties because, like, it's a dead hand. They will never agree with that. Okay, so now let's talk about security here again, both from a system point of view and an app developer point of view. So, as I said, private data is private. It means that only the app can access to the files inside the private directories. It's protected by 2 levels, by the Linux permission system. And if we start to talk about NuGet, by what we call an exception if you try to access files from an app that is not the app owning the private directory. When we talk about the external data, so the SD card folder, and if we stick to the Android function calls, we have permission required to access this folder. So, like before KitKat, it was required this permission for any action, and since KitKat, we only require read external storage to access any folder that is not our own external shared folder. And if we access directly, so not with the standard function call of Android, is still the same. If we talk very quickly about how it works in terms of implementation, so we have 2 levels. These are when we create a directory, we have what we call a daemon that is handling all the security on our behalf. And when we want to access files that is on the external storage, we have what we call a control based by the wrapper at the file system level. So we had before Fuse, which is file system in user space, and now we start to have SD card FS, which here again is a misleading word because it's not the file system of the SD card, but the file system of the /SD card folder, which is not external. And until Q, that will hopefully that we start already after the developer releases. Everything is owned by SD card. So we don't have fine-grade ownership on the SD card. I mean, that will change with Q, and a lot of promises on that. Okay. The other stuff is that content provider, because that's a nice framework to talk when we want to talk about data. We have a definition that is private data setup should never be never be altered, which means that normally they cannot be accessed. However, they can be made readable and editable by what we call a content provider, which should be mandatory starting Q. Here again, another question for some people who want to answer, or maybe like just a general question. Who knows about content provider on Android? Okay, very few. I should have said concept, vulnerability, and analysis tool. Like this morning, you had a workshop about like using Browser, for example, which is a way to analyze insecurity in content provider. Okay, so content provider is first a feature to expose data out of the box. So basically, by just using this framework and doing like this very small line of code, you share your private data folders, let's say in a secure way. But it's also a framework to expose data as you wish. Basically, you don't only expose files, but you can expose database, you can expose queries, you can expose a lot of things with the framework version of the content provider. And so it's a very powerful framework. However, if not fully understood, it's better to stay away from it as a framework because it starts to expose a lot of like you're really vulnerable. However, it's not a reason not to use a content provider as a feature, because by using it with a basic definition, you expose your file in a secure way. Like you just have to pay attention to how you name folders. Like basically here, like you just have to pay attention to this line which says which folder you share. I don't think that's very complicated to do if you want to be secure. Developer perspective. Well, documentation is really complex on Android. Like you have a lot of documentation, a lot of place to find it. So the learning curve is not, is kind of high. And obviously we all very know that the documentation is not the sexiest thing on the planet. Private folder is a constraint. Like if you talk with developers, you will see that private folder is bad because like it's hard to debug, it's hard to share data. Like hard to share data when you have content provider. Here again, it's much more that you don't know, and you don't read the documentation. On the other hand, external folder is great. Like from a developer perspective, it's easy to debug. Like you just plug in the USB and you have access to the to the SD card folder. You have a lot of storage and persistence is possible, and data sharing is believed to be easier. Here again, well, what's the difference between doing like an open file or share file with content provider? Like it's really 20-minute difference. Consequences of this belief of developers. Private folder is mostly used when strongly suggested. I put mostly X%. We will see later what this X% means. Basically, it means that you have a function called get database path. Well, basically, every developer will use it. So databases are most of the time not exposed. However, the external private folder is extensively used because belief has private. And we still have some developers that care about security. I put that in quote, because basically they care. First trick, where we put the file in the /sdcard instead of my data. That way nobody will find it if they try to find my data on my folder. Second trick, we will make the folder name or the file name invisible by prefixing with dot. Like that's the way in Linux to hide files, unless you do but like if you do ls-a is there. And third trick, like if you store media, one best practice is to use what we call a media manager intent to say my data is here. Well, one way to hide your file, according to developer, is not to do this intent, so nobody will know that files are on the SD card. Here again, that's very bad and old practices. Okay, so now that we see the developer perspective, what does it mean when you have an Android phone? Like what really happen in real life with real application? Okay. So the initial objective was we report any non-explicitly shared data that we see. I didn't head well because most of the time the response was, well, it's not critical exposed data. Really, you expose user data, corporate data, but it's not critical. Ask your user. No better option. I had the answer that, yeah, we know we expose the data of the user, but we don't have any better option. Well, yes, you have content provider. Or the third answer was, yeah, we know that per default is insecure, but user can change the storage location. Really now you start to blame your own user for bad per default configuration. So that was not good, and like after maybe 1 month or 2 months of sending this kind of report, like it started to be very depressing. However, like I always have the same picture, like I'll be back. It's always the same output. Is like we upgraded the objective to say to people like, come on. Now, like you cannot say that it's not important. Like we show that we specifically target data that is per definition not right to share. That's the only way to put these people like in front of the issue and they cannot say anything. So basically we show that we can expose user identification, application secret, user password, user web activity, corporate data, and user sensitive data. And non-deniable leaks. But still, as we will see, even if that's so obvious that this should not be shared, it's still very complicated to make vendors agree with that statement. So the candidate was that we don't target any apps. Like we wanted to, like, here again, target people that normally know their job and when we discuss this kind of report, agree with us. So basically we try to target this kind of, issues. So as I said, user PI, emails, user profile, password, bank information, authentication, token, credential, protocol, identification, browsing, I mean, all of that stuff. We try to see what we can do. And this is very interesting is that basically most of the major app leaks this kind of data. And when I say most of the major app, like there's a number of downloads officially in the Play Store, like you see that emails are disclosed by app with 2,000 download, user profiles with 5.5 billion, password 100,000, bank information 6 million. I mean, like, I will not make the vote list, but like basically we had an expectation to target still a good, a reasonable size of the user base to say like, like, come on, like you're handling the data of millions of users, like you should really care. Okay, so how do we look for bugs? So we first try to categorize the issue we want to target, then we listed the relevant candidate for, say, target. We detected the issue on one of the apps, so it's like a manual step. Then we try to categorize this issue and define a reproduction pattern. We run, then the idea was to automate this analysis, which obviously was not really possible. So basically the only thing that was automated is the brain, meaning we know how to look for a bug, we know which bug to look, and basically we install, we look, we install, we look. So we should have some part of automation, which is the brain pattern. And then obviously after we did that, we restart at one. So it was really this kind of game. And that I will present now. Okay, so first one, how to get user identity from logs. Logs, I mean, like everybody knows here, logs contain a lot of data, really a lot, really too much. And developers basically have this nice stuff that when they put logs, they basically want to they want to easily use them. Basically, they will put on these logs data, IDs, everything that identifies the user from the stand of view. But it's also true for any attackers. Like if by looking at a log, an app developer can know the user, well, any people who access the log can know the same thing. For example, here I just put here two example of logs that we see. We see on the first one that basically the user ID is disclosed and the email when we try to log in. So basically, just by looking at the log, we know the user email address without any permission except read external storage. Another one was that basically we were leaking the account token. And the account token was a way to access user gender, user email, user first name, last name, phone number. So just by looking at the log, we get very nice information. So how we detected that, we made a script that basically every time we install an app or set of app, look for by grep email address or keyword like auto token. And by only doing that, we get like all this information. How to avoid that? Well, it's very easy. Clean your logs. I mean, like, don't put user PI on the log. That's stupid. And keep them private. I mean, like saying that we put the log on external storage because they are too big is kind of nonsense. Like you can zip them, you can rotate them. I mean, like it's very bad best practices regarding logging, and like you already have framework to do logging correctly. Another way to extract user identity is based on naming convention, which was another funny stuff, which is like basically a lot of apps nowadays handle multiple accounts within the app. So social networks, data management application. And they need a way to separate data sets. I mean, like account 1, account 2, account 3, they are different folders. And the insecure approach that we often see is basically to use the user email address as a folder name, or to use the user ID as a folder name. Well, I just put here 2 lines. So one was like when we were using the app, my email address was disclosed every time. And when using other app, offline cache, where the social ID was disclosed. And we don't pay attention, or like the social ID is a very weird set of letters. So when you look at that, you don't understand what it means. And luckily for me, well, I know very well this social ID. So when I look at this folder name, I say like, it rang the bell, and basically it was the raw, complete social ID, social network ID of the user. So by just looking at file names, we know who you are, without asking any relevant permission. So the detection method is basically, instead of grep while you do find, well, like it's very, very straightforward. And what the best practice is, don't do that. I mean, like here again, you can hash. You can do like an internal mapping on a private database. That's here again, best practice is like, don't put an email address as a folder. I mean, like that makes no sense. So you can hash that. I mean, it's the same unicity. So user profiling was the second issue we're trying to do, meaning like, let's assume that your identity is protected. Can we guess what's your preferences? So basically, we had the statement that the raw IP address is not a sufficient leak. It's too easy to get on Android, like while you're browsing on the web. So we wanted to know exactly when, what, and where you are doing. So one way to basically do user profiling on social network application is basically to look at the cache, because every time you visit a page, where you get somehow some cache that is shared on external storage. So the first cache was that basically every header of the page you visit on this social app was cached. And the header is unique to the page, so we know exactly which page you are visiting when, or at least for the first time. The second way is to get the user identity by looking at the picture cache, the user picture cache. The first picture is your picture. So basically here again, we're not talking about an application with like 10,000 downloads. We're talking with application with billions, and the file, the picture file, can be easily Google reverse picture to know who you are in matter of seconds. Another very interesting thing is web browsing. So if you lose some web apps, they will cache what we call the web view in the external storage. And basically the web view cache is the whole page. So we know everything that you visit, which page, and sometimes we even get the credentials that you use within the page. And here again, how to avoid that is basically to assert the behavior on the underlying component you are using. Because most of the time, this app don't even know that they are leaking this information because they use some kind of image generation, or they use here, for this case, a web view component that is not their own development. Okay, so another one is playing with geolocation. So when dealing with maps and GPS, you often have a lot of data. And the insecure approach is to consider that all GPS data are similar, meaning you save everything on the same location. And when I say anything, is for example, well, the user database associated to the GPS map that you download, where you put them next to the maps. I mean, like, it's kind of logically makes sense. When you're not developers, you put all the logically linked data in the same location. Well, I mean, here, for example, like it was a map application that serialized the values of your preferences. Well, I mean, it's okay, you get the SQL database, you don't understand what the format is. Well, you just play some kind of guess, and you see very quickly just serialize, and you export everything. And the way to detect that was basically to look at any exposed SQLite database on Android on the external storage. Well, here again, it's just a basic grep about SQLite. And two things here. Don't believe that read external storage is the same as access file location, like assert the value of the data that you are storing. And the other thing is that don't believe that because you use a custom format, users will not be able to, attackers will be able to understand what's the format, because they can just install the app on another device, put the file, and that the file is run on the app. So another way to play with GPS location is regarding integrity. Here we have some SQLite database that is not even serialized at all, not encrypted. Here again, same pattern of detection. And basically, we can insert third information in the GPS of the GPS app, meaning we can insert fake route, we can insert fake preferences, alter the preferences, and basically just destroy the user experience, for example. Okay, extracting implicit confidential assets. So documents are often saved on device only for one reason. You want to have offline support, meaning like if you are a corporate and you have data, well, you want to save them on your device because you want to access them locally. And the insecure approach is to consider the documents when are not sensitive. And the second stuff that is linked is like basically as it's not sensitive, users don't need to know where we store them. Okay, so here was a small mistake. So the example is that basically users hardcode the storage location and don't say that to the user. The second thing is that, well, you hide the capacity to change the storage directory. And basically, we only had to detect file change, which is super easy, like we have file observer that we can extend to path file observer on Android, and basically we are aware every time a file is inserted on the external storage. And here again, the only mistake is that, well, I mean, first don't make that static on the external storage because like some people that use your app may want to store confidential data and they want to know where it's stored, or at least to choose that. And the second option is that, I mean, let the user decide what they want to store and make it by default secure. Like if the user wants to have a lot of data, just give him the option to put that in the external storage, but don't assume by default that it's an external. Like it's not your data, it's your user data. When we extend about this confidential data, we can talk about explicit confidential data, which is like encrypted documents. And here again, most of the times the approach is exactly the same, which is we don't tell the user where we store. And another consideration is that as we are on an Android system, we don't give the encryption key, like we keep that on the server, like, you know, it's top secret, top important. So we don't share that on the Android system, which is here not a bad vision. But the issue is that when you store file in the app external folder and you want to allow them to view, well, you have an issue because you don't have the encryption key. So basically what this app do, is basically they will take the sensitive data, encrypted data from the server, they will put that on the external storage, and two options. First one is that we just put them unencrypted because we don't have the encryption key locally, or we decrypt them on the fly and put them on the external storage, which in the end is the same. We have an encrypted confidential material on the external storage. Well, detection method is really exactly the same. It's like we just monitor for file change. And like, yeah, I mean, like just here again, pay attention when you store files. Just pay attention to what you store and how. Like when I was talking about this explicitly confidential data, it was even a feature on said apps that said we use this kind of vault or like secure vault or encrypted folder feature. That is a paid feature, but basically it's just like a folder on the external storage next to the unsecure folder. Okay, extracting explicit confidential data. I will just check the time. Still have some time. So, when we want to extract confidential data, the other stuff is that basically when you SMS, no MMS, most of the users will believe that, well, it's fine. Files can be stored, like the files that you put on the MMS, is shared. So we put that on the shared storage. I mean, like basically you expose any data sent by MMS to any application installed on the device, even if you call them private. And even if it's not an MMS app, it's just like a conversation app inside the banking application with your bank manager. Some people have the consideration that as you share with someone, well, it's shared with everybody. So the detection method here again was super easy, just like install the app, play with it, and see what's disclosed. And one way to do that better is just to assert how data is generated. Like if you exchange an MMS with a file that is already stored on the SD card, yeah, it's fine to cache it on the SD card. But if it's taken from the camera, for example, you take a nice picture of yourself and you want to send that to your partner, well, maybe you don't want that to be disclosed to any other app installed on the device. Okay, next one, injecting private data. I was talking about how we can access data that is stored on the external storage. Another thing that is really nice is that basically you can do the same in terms of alteration. Basically, a file is stored on the external folder, like a remote file, like for example a corporate data file that is stored on a server. Well, if you're an app, another app, you can just overwrite the file locally, and the next time the user will open the data management app, it will sync back to the server the modification that you made, which is quite cool to upload any data that you want on the corporate server. One of the things what's possible is that basically, if you want to share file, like like you have this share feature, like I want to share to the Bluetooth, by Bluetooth to another device, or I want to share by email. Most of these apps, what they do is that they will store the temporary file that is the action between sharing to the other app in the external folder. And another thing that is really super great is that basically it will even disclose the fact that they put that in the external folder. So as an attacker, you just have to basically at this right time alter the data so that the genuine sender set a malicious file to the receiver. And here again, when you are talking about bank application, well, basically, the bank manager will trust your input because he believes it's your input, while it's not. Okay, so I think I'm running low on time, so this is exactly the same stuff, so I will just skip that one. And I will talk about extracting shared private data. You have to understand that when you disclose data, you don't disclose data. When you disclose two data, you don't disclose two data. Well, you disclose two data and the aggregation of said two data. And that has to be considered carefully, because, for example, when you disclose action traces or interaction traces, well, you disclose the whole trace. You don't disclose each line individually. Which means that attackers, for example, here, when they see this kind of line repeating, know that, for example, this ID here is always, so it was for a remote control application, was always disclosed, basically the controller ID was always this one with that name, that one. So basically we can start to know who connect to the device of the user by this disclosure of internal data that seems not important. And what is great with that is basically we can, as an attacker, fake remote connection by using the same, not the same ID, but at least the same name, and the user will get a pop-up that someone with the same name as the one we have that used to control all device wants to connect to us. And I will not disclose the exact reposition steps, but basically we can just cancel, sometimes we can even cancel the genuine request and replace with wrong, and the user will still believe that it's the correct user because the name, which is the only information displayed, is the same. Okay. So extracting user secrets, some data, some in-app data are de facto sensitive. Like it's not a question. And it's wrong to secure that every data that is processed within the app, as is processed within the app or is viewed within the app, can be disclosed. And here, for example, I'm talking about like when the app connects to the remote server and there is a failure, and you want to log this said failure, basically don't assume that the failure is caused by the user wrong inputs. Because when you do that, well, basically you put on the log email, first name, last name, and password, which sometimes, if it's a server-side mistake, is a real is a password. So basically on the log you put the user email and password. Well, that's great. Same thing when someone is viewing content and the app. It's not because they're viewing that on the app that you can disclose the bank account. Some bank apps, when you look at the bank account within the app, just cache that because the PDF that need to be rendered, so it needs to be stored locally, but it's temporary. So we just put that on the shared folder. That's not right. Okay. So evaluation of the study. I'm just thinking. Evaluation of the study. So analysis process. It was a really time-consuming stuff. Like we spent months because it was manually installed to each app because we had to sign up most of the time. We had permanent retraction, meaning we find a bug, we generalize, the generalization is not good, so it was like a permanent stuff. And the standardization is really hard because most of the time the bug is different. It follows the same logic of incorrect disclosure, but the way it's disclosed is never the same. So after months, we started to have general pattern, but it was not a straightforward stuff. And it often relies on the combo install an app, find potentially vulnerable file, grab for disclosure. I mean, like that's really like, you have to target the wrap app category very quickly, otherwise it starts to be very unpleasant that after days of installing apps, you find no bug. I mean, like when you find the right category, all of them are vulnerable, but unless you find that, it's really like not nice. So classification of the issues. We have a lot of type of data disclosed. We have app private data, we have user private data, we have device protected assets such as geolocation. And the reason for this exposure is really limited. I mean, the first one is that most of the time app developers just failed to read the documentation. They then fail to define, like he's even not asserting, is defining the security policy. Like if you don't define your security policy and when you consider as public and not public, well, I mean, like it's stupid because like everything is disclosed in a way you don't even control. And the third type of failure is like not to perform any security tests because it's very easy when you are the app developers to just check where your files are stored in live scenario. Most of the issues were here discovered because there was no security assertion at all. So classification of the vendors. So we have, for people who do bug bounty, I think they know that already, various vendor profile. So we have the really responsive vendors, like the top one that respond very quickly, couple of days. Most of the time it's managed by bug bounty platforms, but not always. They acknowledge the issues, pay or give 1 year subscription to the software. I think I really prefer the payment option. Then you have the non-trustworthy vendors, which people that basically see your issue, just say, oh yeah, it's out of scope. Because, you know, like when you do bug bounty, you have a scope. Even if the issue is bad, well, they can still say it's out of scope if it's out of scope. Or they will say won't fix for maybe 2 reasons. One is because the product is end of life. So what we see a lot with device manufacturer. Or it's too much work to fix. So it's a question of benefits versus cost. And then you have this third type of vendor, which is majority of them, which is the ghost vendors. You send them email, you send them a second email, you send them a third email, no reply after a couple of months. But for the third one, type of vendors, I will say that's not the right approach because basically we're talking with Google about like what can we do? I mean, like when we're talking about 80s or plus vendors that disclose millions of user assets, I mean, obviously for us, the next step that was to escalate that to Google Play team, and that's work under progress. Classification of the vendors. After who kind of reply, then we try to understand what's the vision of them. And the first issue we had is like really how to explain the issue to them is really complicated. We have to explain to them why disclosing user email address or user identity is bad. I mean, like normally that's their own business, they should know what's bad. We have to disclose also to illustrate how sensitive the data is disclosed. I mean, like when you disclose user business such as corporate data, encrypted corporate data, normally we don't have to explain why it's bad. For content provider that I mentioned before, we even had sometimes to explain what does path transversal vulnerability means. I mean, like it's a very well-known security issue, very bad for the whole operating system. But most of the time, vendors just say you have to specifically tell me why path transversal vulnerability is bad. I mean, like you just have to type these keywords on Google to find why it's bad. And the reason most of the time is because you should pay attention. When you talk to vendor, you have two business involved. You have the vendor business involved, and you have the users of the vendor application business. And when you start to go against the vendor objective to protect the user business, sometimes it starts to be very conflicting. The other issue is that most of the time it doesn't even worth the effort. When you have no reply, when you get a 1 year subscription, or when you get a T-shirt, I mean, like, it's cool, yeah, but when it takes hours to find the bug and more hours to explain the bug, I mean, a T-shirt is not really enough. And the last part is that even if you show everything written the issue, even in that case, changing the vision vendor is very hard. Okay, so conclusion. Even if I say it was very complicated and time-consuming to do this kind of survey, I mean, like, it's very interesting to do what else we can say, like, similar to dumpster diving on Android, because basically you're looking for a needle in a haystack, except that you don't even know what the needle is. And most of the time you don't even know where the haystack is. So it's very challenging. The analysis, as I said, was partially automated on the pattern side, but on the other side, most of the time manual, except that it is often reproducible, which is when you find one, well, you can be sure that if one developer made this mistake, a lot of did. And still, a lot of work is possible in this kind of study, and I hope that some people will be interested to do this kind of study too. We can build a real automation tool, meaning like really like put far less constraints on the manual side. We can extend the type of disclosure analysis and the candidate, because basically, as I said, we targeted huge user base, which normally means that developers are already very aware of what they do. But what happens when you have an app that has 100,000 downloads? I mean, like, we're talking about already 100,000 users, so potentially it's disclosure of 100,000 user data. We didn't look at this because we just like have a higher expectation in terms of user base. And another potential work is basically to use this disclosure to get even more exposure. For example, when we get token ID, going back to like understand how this ID is used in terms of API, as we did for one study, can disclose even far more data than the one that is on the device. Because if you disclose the authentication token of an API, where you can get all the user profile, even if it's not on the user device. However, one small stuff here is that we will work on that again, but two things here. To prevent this kind of issues, it strongly depend on the vendors. Like, if they get notified and don't fix, it will never be fixed. And the second thing is that if they still behave the same way as discarding most of the time these kind of issues, well, it doesn't even worse for security researcher to do this kind of work, because like it's a lot of time for basically nothing. Okay, so thank you for your attention. If you have any question.